Good morning, everyone. And my name is Wong Kian Singh, and I'm from DIS. And today I'm going to have a presentation is regarding the introduction to the operating system. And of course, this is a part of my assignment. So I'm going to upload this presentation video into my CNE portfolio after I done recording this. So without further ado, let's start to the today presentations. Okay, so first of all, what is operating system? Operating system is actually just like a software. They serve as an intermediate between the computer hardware and also the user applications. So we can just think it like it's in the middle of the user uh, applications and also the computer hardware. So it can enhance to let them communicate without any error, and at the same time it can managing and coordinating various system resources to enable efficient and secure operations. So what is the example of the operating system? For example, it can be the Windows, like what you're using, usually what is the end user will be using, and Android, your phone, Linux, and also the iOS. Okay, so what is actually the OS will do? For the first one, very easy. Resources management, which something that just now I have some mentioned, which is called a locating and managing hardware resources like the CPU, memory, disk space, and also the peripherals, which is the your display. And process management, uh, it can be handling processes, multitasking, and ensuring efficient execution of the program. And file system management and device management, and also the last one is the user interface. Actually, you can easily get the idea from the name of the basic roles. So next one. Okay, so let's go to the first activity of the today's section, which is a flowchart. And we need to know about how the operating system perform when to print a multi-page document on a single user computer system. So let's check to the flowchart over here. It's a bit small. I'm going to make it larger. Okay, so for the first one, start ready, right? We will have the user input. So for the user input here, can be using the Control P, or either you can use the mouse over here. You can just click it to the file and then you click print. And then after that, you get the user input to the operating system. The application will communicate with the operating system. The applications can be the Microsoft Word file, or maybe the PowerPoint file over here. And after they communicate ready, right, the OS will call for the file management and also the IO handling, which is the input output handling, to locate the printing file. And then the OS system calls for the device manager for the printer driver. I mean, everything you need a driver, right? If you install something, they actually have driver inside there. And it could be convert the document file into the format that are printable, so the machine can be understand. And then we will store all the pages in the print queue, which is a technical way is called a spool. Okay, and then print to the printer. Okay, so for after the first page to be print, it will be asking to the printer again, is there still page to print? So if it yes, you will go back to the print and print to the printer. If it is no, it will just display printing finished and display the printing completed to the user. So the user can notice, right? And then and this is very easy only, but actually can be more complicated, but I'm not going to explain through it. Okay, next one. So right now we are going to talk about the memory allocation over here. So memory allocation, just now I told you, right? The OS have a basic role is called resources management. So it's going to have management over the RAM as well. I mean, the RAM is very important to the all the machines over here. If it doesn't have a RAM, even you can't going to operate your PC over here. So you can just think it like this. So actually here, the memory allocation, they have two main methods over here. For the first one, we call the fixed partition. You can just think it like the RAM have maybe 4 partition over here, and each of the partition here is actually already have a fixed size. And in this case, there are actually 6 MB, and we have 5 processors over here, or you can just think of like jobs. So you have a P1, P2, P3, P4, P5, and P1 are going to sub into the partition 1, but I told you, right, you see that 3 MB. But the partition 1 have 6 MB, so 6 minus 3, there will be 3 left. So what is the left called? It's called the internal fragmentation. So internal fragmentation is actually just a space that is been wasted, means you cannot be using again, because the other process is going to sub into the another partition without instead of subbing into the partition 1 again. So in this case, P1 going to 1, P2 going partition 2, P3 3, P4 4, but you see the P5 cannot be subbed in because all the partition is already full. And even though you have many of the internal fragmentation and many space, but you still cannot use it, because I told you one process must be only sub into one partition only. So this actually, come to a very problem called internal fragmentation. Okay, for the second one methods, we call the dynamic partitioning. Okay, so this is actually a upgrade version of the fixed one. Just now the fixed one is all this is 6 MB, right? But inside here, it doesn't have any 6 fixed value partitions. All right. So after the operating system already, you can see they will label it 896K size over here. So if the process one come in, the processor may be 320K, right? You sub into it already. Okay, you still see the downward still have 576 over here, which is the left one, and process 2 can come in, and then the process 3 can come in, and you can see the internal fragmentation only 64. I mean, yes, it is more better than the fixed partition already, right? It doesn't mean like, the process one after you feed in already still have the internal fragmentation. So it comes to a conclusion. Okay, the dynamic partition can actually let you to ngam fit into it without having any internal fragmentation. If there is the left space, then you can just let the process go in and go in. Okay, so without having much, even we can't say that 100% will be canceling all the internal fragmentation. It is hard, okay? So, but this is, improving really. Next one. Okay, to solve the issue of the insufficient physical memory, just now I told you, right? Because the process file, we cannot sub into it because we have less space and less partition. So right now, we need to use something called a virtual memory. So actually, this virtual memory is also a function on each of the machine right now, which is your computer and also your phone. You can enable this function. Okay, next one. So what is virtual memory? So virtual memory is an abstraction of the computer physical memory, and it is allowing the operating system to use the combination of RAM and disk space to provide the illusion of larger contiguous memory space. And it is primarily used when the RAM is full, or when the system maybe need for the prioritize for a certain processes or jobs and over the other. So it can be swapping to the secondary storage over here to uh, minus the issues of the insufficient space over here in this case. So right now we're just going to give you C for the image so you have a better understanding. So for the first one here is the process of the virtual memory. Yes, just now I told you, right, virtual memory is something like the RAM is already insufficient space. We are going to borrow some space from the secondary storage, which is in this case the hard disk, and as you can see inside here got 1, 2, 3, 4, 5, 6, 7, 8, right? So for example, inside the RAM only have 4 partition and it's actually full, but it still have one more processors is waiting to need to sub inside. And that one is actually you need to use it simultaneously also. So maybe the first partition will be swap it out first and store into the hard disk and let the process 5 go inside. And maybe after the process 5 done ready, okay, and then just now the process 1 will be subbed in back again into the RAM. So it could be make it more prioritized, or maybe there will be a rotation. Okay, always rotation, and make all the processes done. Okay, so right now in the back one. Okay, so is merchant memory viable? First thing, yes, of course. It can eliminate the fragmentation by consolidating the memory into a single free block after copying back the memory from the secondary storage into the physical storage. And also, but it can be a cons when it comes to the secondary storage, the write speed is not very, very good. If it is not very good, then maybe a time-consuming process to you. Okay, so anything that we can make the compact memory better. So first thing, maybe we can develop a smart relocation algorithm considering a job size and execution characteristic and prioritize something, maybe a smaller jobs, and then you can minimize the fragmentation, and then implement a dynamic compaction trigger based on the memory usage and the fragmentation thresholds, and use the incremental compaction in stages focusing on specific memory segments for efficient rearrangement. So you can just think it like we are combining all of the methods in front that I have mentioned, and then we are going to have maybe a tidy up chance in a certain period, so it can make it more neat and clean without or having many internal fragmentation inside there. So, if not, it will become very slow and also problematic. So I mean, using the virtual memory right now is very good also lah. Okay, next thing. Okay, so right now we are going to talk about how the page been swapped in and swapped out also. So just now we say the virtual memory is using the swapping, right? The method over there. So there actually in the swap in swap out have also another two methods. Okay, first one will be the first in first out, and the second one will be the least recently used over here. So let's go see into the activities instead of explaining that. So for the first thing, even the memory is the composed of 4 page frames for public use. Use the following table to answer all parts of the problem over here. So for the first questions, the contents of the which page frame would be swapped out by using the first in first out over here. So you can see over here, since there are 4 page frames are loaded in a sequence of 0, 1, 2, 3, 4, 1, 2, 3, and the use of the first in first out basis. Okay, so therefore, for the first one who been swapping in, I mean, the first one will be going included into the memory is the 0, right? The page frame 0. So therefore, the page 0 will be going to swap out first. Okay, and the second question is over here, the content of which page frame will be swapped out by the least recently used. So least recently used is meaning will be swapped out the page frame that have the shortest time when last reference, right? So therefore, the answer is the page 2. Why? And you can see the time when the last reference over here, only the page frame is 294 and 300 below, the others is 300 above. So that means this is the smallest one, and it is the least time for the reference. So yeah, the answer will be the page frame 2. And now we are going to talk about what is the process and also the threads. Or actually, you can just think it like this. The process is an instance of the running program inside of your computer, and the thread is actually inside of the process. It is hard to visualize, right? So right now, we are just moving to the next slides. So as you can see in your top left over here, you can see there is an image, there is a process, and it is including 2 different threads inside. So what is the difference of these two actually? So the process is an instance of a program that being executed or processes, as I just now mentioned already, and thread is a segment of process or a lightweight process managed by a scheduler independently. Or easy way, you can just think it like this, okay? The program consists of the process, and process consists of the thread. All right, and then the process is actually independent, and it is not share memory or resources to the others. And the thread is actually is dependent and share memory with the purge threads over there. Okay, so each process is treated as a separate entity by the operating system. So each process in actually, okay, here got one process and another one process over here, third, fourth, they all is separate. But for the thread over here, the operating system is treat all user level threads within a process as a single entity. So inside of a process, you have multiple threads, right? But this all thread, the operating system just only treats all the threads here is as a single entity without separate them. So that's all. And then because of this, right, you can just think it like this. The process, if you want to like start it up or terminate it, so it going to takes more time to terminate a process or start up a progress or of a process. But the threads, it can be also of course it will be more faster lah, right, compared to the of the process, because the thread is just very small, so it can terminate or start up very quickly, relatively quickly. You know? So let's come to the example over here. So the example, the web browser itself, like the Chrome, Microsoft Edge, the Firefox, this always can consider as a process. All right, and then the web browser inside, you can open many tabs, right? So like for example, if the first tab you open a Facebook, the second tab is the YouTube, and yeah, actually when you open these all the tabs very fast, you can be more faster than opening a process over here, which is the Chrome or Google something, and that's all. Okay, next slide. Okay, right now we are going to talk about the process synchronizations, or you can just think it like this, like For example, a printer, right? A printer, you can control it by a phone. Maybe at the same time, there are two phones are controlling a computer at the same time. So this come to a synchronization, right? Either that the printer are going to follow for the first phone or going to follow to the second phone over here. Okay, let's see. Because that actually will causing some problems, right? If two of the phones are sending some requests or getting some requests back at the same time over there. The printer also don't know which to follow, right? Okay, so let's see what is kind of the problems over here. So for the first thing will be called a deadlock. Okay, second will be the live well and raise and starvation over here. So let's move to the deadlock first. Okay, so deadlock, you can just look at the picture at the right bottom over here. Okay, so we just related to the real life example. There are two drivers and approaching a four-way stop intersection simultaneously. Each driver politely gesture for the other to go first, like this lah. Like the one car is saying like, you go first lah, you go first. But the other car is like, oh, you go first, you go first lah. So these two cars actually not moving. They are like giving each other some gestures saying, oh, faster lah, you move first lah, you first lah, but no one is moving. So this is like causing a deadlock over there. No one is moving. So what kind of resolution over here can be used? So you can implement a clear rules or traffic signals at the intersection to design it the right way and animate the ambiguity, resolving the deadlock. Next slide. All right. So right now we're going to talk about the live log. Just now it's the dead one, right? That one. So now it's a live one. So the real life example, you can just picturing two people trying to pass each other, like the picture that I placed at the right bottom there. So they are in a narrow hallway, and each individual like keeps stepping aside and to let the other pass. So they are actually continuous edges. So they are actually like moving. They are moving at the same time simultaneously, but is without any progress. So this is actually like a live log lah. Okay, so what is the resolution over here? Is introducing a simple communication gesture like making eye contact or signaling the intention to pass to break the live log and facilitate the smoother movement over here. So let's see about the third problem here. Okay, so this is the race. So real life example, imagine a group of friends. Okay, they are signing in a maybe the birthday card over there, and then each of them is signing writing something that is very heartfelt messages. Okay, but they are trying to racing with each other individual who are writing the paper as well. Okay, so like people who are like racing, like racing and trying to write whatever they can write inside. And then at the end, it is a mix of everyone writing in the final card content. And yes, this is causing very complexity and problematic. So what is the resolution over here? So it can be implementing a structured approach, like maybe who can design an order lah, like for who are going to sign first, and then the next one, next paper. So this can prevent the race condition and maintain a coherent message over here. So let's move to the last problem and also the last slide also. So this one is the last one, real life example. You can just think it like this very easy way. In a classroom, all of the students here is very smart, and of course the lecturer is very like it, but there are only one student who are not very smart, and maybe he's trying, but it doesn't do anything, and the lecturer like just ignoring him because he is not good as others classmate in the class. So the guy, the one who are not smarter, will be ignoring and will be waiting for a long time. So in the opening of the resolution is something like maybe the lecturer can ask for the student, right? And then asking him for any opinion or anything you want to ask. So therefore, everyone over here can have the chance to talk. So these all four problems can actually lead to the problem of using the printer, like just an example that I have shared. Before this. So this all can related to the printer problem lah. So I think that's all for the presentation ready, and thank you for the listening. And right now I'm going to end this. Thank you very much.